We've all seen this image, the first photograph of a black hole. It appeared in news articles, documentaries, science videos, and probably all over your social media feed. But there is one problem. It isn't actually a picture of a black hole. In fact, despite everything humanity has achieved, nobody has ever seen a black hole. Not once. Not through a telescope, not in a photograph, not in the visuals on your screen right now. We've measured them, we've detected them colliding, we've seen them tear stars apart, but we've never actually seen one. So if we haven't seen a black hole, what exactly are all these images showing us? To understand why nobody has ever seen a black hole, we first need to understand what it actually means to see something. Everything you've ever seen is visible because of one thing: light. The screen you're watching right now is producing light. The walls around you are reflecting light. The moon is visible because sunlight bounces off its surface and travels into your eyes. Even the most distant galaxies we photographed can only be seen because they emit enormous amounts of light. Black holes are different. Unlike stars, they don't produce light. They consume it. Unlike planets, they don't reflect light. Its gravity is so powerful that once light crosses a boundary known as the event horizon, it can never escape again. Not tomorrow, not in a million years, not ever. And that's where the problem begins. Imagine trying to photograph something that emits no light, reflects no light, and traps every photon that gets too close. It's like trying to photograph a shadow in a completely dark room. There is simply nothing for your camera to capture. This is why black holes are fundamentally different from every other object in the universe. They are not just dark objects. They are invisible objects. And yet, despite being invisible, black holes are some of the most studied objects in astronomy. Scientists know their masses, they know their locations, they even know what happens when two of them collide. Which raises an even stranger question. If black holes can't be seen at all, then what exactly did they photograph in 2019 when the world celebrated the first image of a black hole? In April of that year, headlines around the world made history. Scientists captured what was described as the first image of a black hole. The image quickly became one of the most famous photographs ever taken. And it's easy to see why. For the first time, humanity appeared to be looking directly at one of the most mysterious objects in the universe. But that's not actually what happened. The image you are looking at was captured by the Event Horizon Telescope, a network of radio telescopes spread across the Earth working together as a single giant observatory. Its target was a supermassive black hole located in the center of the galaxy M87, over 50 million light-years away. The achievement was extraordinary, but the black hole itself was still nowhere to be seen. That glowing orange ring isn't a black hole. It's superheated gas, matter that has been heated to billions of degrees while spiraling around the black hole at incredible speeds. The black region in the center looks like the black hole, but even that isn't entirely accurate. What we are actually seeing is a shadow, a dark silhouette created by black hole's immense gravity that bends and captures light around it. The black hole itself is hidden inside that shadow, completely invisible. In other words, the most famous black hole image ever taken doesn't show the black hole. It shows the effects of a black hole. And once you realize that, you start seeing a pattern. Every black hole image you ever seen seems to have one thing in common. You are never actually looking at a black hole itself, you are looking at everything around it. In fact, almost every black hole you've ever seen falls into the same category. Take Interstellar, for example. The film's black hole Gargantua is often praised as one of the most scientifically accurate depictions ever created. And that's true. Scientists collaborated with the visual effects team using real equations from Einstein's theory of relativity to predict how a black hole should distort space and light around it. The result was so accurate that it even contributed to scientific research. But Gargantua still wasn't a photograph. It was a simulation, a prediction based on our best understanding of physics. The same is true for the black hole visualizations used by NASA, ESA, and countless documentaries. They are not fake. They're not trying to deceive anyone. They are visual interpretations, scientific reconstructions built from observations, equations, and computer models. It's kinda like a forensic artist drawing the face of a suspect from witness descriptions. The drawing may be incredibly accurate, it may even be almost identical to the real person. But it's still a reconstruction, not a photograph. Black hole images work the same way. Scientists observe the effects of a black hole. They measure the motion of nearby stars, they detect radiation from superheated matter, they study how gravity bends light around it. Then they use that information to build a picture of what should be there. And that's the closest we've ever come to seeing one. And now I'm starting to wonder, if black holes are invisible and every image we've ever seen is either a shadow or reconstruction or a simulation, how can scientists be so certain that black holes actually exist at all? And at this point, we all might be wondering if black holes are simply one giant assumption. After all, if nobody has ever seen one, how can scientists be so certain they exist? The answer is surprisingly simple. As mentioned before, we may not be able to see black holes directly, but we can see what they do. Imagine walking through fresh snow and noticing a trail of footprints. You can't see the person who made them, but you know someone was there. Black holes leave behind clues in much the same way. One of the strongest pieces of evidence comes from the stars orbiting the center of our galaxy. For decades, astronomers carefully tracked their movements and discovered something strange. These stars were racing around an invisible object containing millions of times the mass of the Sun. Something incredibly massive was hiding there. Something we couldn't see. Today, that object is known as Sagittarius A star, the supermassive black hole at the heart of the Milky Way. Black holes also reveal themselves through violence. When gas, dust, or even entire stars get too close, they become trapped by the black hole's gravity. As this material spirals inward, it heats up to extraordinary temperatures and begins emitting powerful radiation that telescopes can detect across the universe. In some cases, black holes launch enormous jets of energy stretching thousands of light years into space. And then there are gravitational waves. In 2015, we detected ripples in space-time itself. The signal matched exactly what Einstein's equations predicted would happen when two black holes collided and merged into one. For the first time, humanity had effectively heard black holes crashing together, not by seeing them, but by detecting the effects they left behind. And when you combine all of this evidence, the picture becomes impossible to ignore. Black holes consistently explain what we observe better than anything else. Which is why astronomers are so confident they exist, even if they never actually seen one. But that still leaves one final question. Will humanity ever see a real black hole? With every new telescope, humanity pushes the limits of what can be observed. We've looked deeper into space than ever before. We've captured galaxies from the early universe. We photographed planets hundreds of light years away. And we even managed to capture the shadows cast by black holes. So surely it's only a matter of time before we finally see one. Right? Well, maybe not. The problem isn't that our telescopes aren't powerful enough, the problem is that black holes fundamentally refuse to cooperate. To see something, light has to reach your eyes or your camera. But a black hole's defining feature is that once light crosses the event horizon, it can never escape again. No matter how advanced our technology becomes, there may simply be nothing to see. Imagine trying to photograph complete invisibility. Not darkness, not a black object. The complete absence of information. That's the challenge astronomers face. Future observatories may give us sharper images of the matter surrounding black holes. We will probably map their shadows in greater detail. We will measure their properties more accurately than ever before. And we may even discover entirely new ways of studying them. But seeing a black hole directly is a very different challenge. In a strange way, black holes may be the ultimate cosmic illusion. The more we learn about them, the more we realize that everything we observe is happening around them. The glowing gas, the distorted light, the violent jets of energy, and the gravitational waves. But the black hole itself remains hidden at the center of it all. And that's what makes these objects so fascinating. Not because they are far away, not because our technology has failed, but because the laws of physics themselves may prevent us from ever seeing them. So the next time somebody shows you a picture of a black hole, remember this: you are not actually looking at the black hole. You are looking at the matter surrounding it, the light being bent around it, the shadow it casts against the universe behind it. And perhaps that's what makes black holes so fascinating. They are among the most powerful objects in the universe, yet they remain hidden from view. Thank you for watching, and as always, keep looking up.